Alright, here we go. 6.3, the last lesson of 2017. So, you already know the properties of parallelograms. We learned those in lesson 2. Would y'all take your headphones out, please? So, we know the properties. Now we have to learn to test quadrilaterals to see if they are parallelograms. So, there's actually 5 tests. Okay, there's 5 tests. And if it passes one, then it's a parallelogram. So it only has to pass one test to be a parallelogram. So there's 4 that you see right here. But there's actually one that's right here that doesn't have a picture. So it says, if a quadrilateral has each pair of opposite sides that are parallel, by definition, it is a parallelogram. So your very first test is if you have a quadrilateral and both of its opposite sides are parallel. So it should have an arrow, and then 2 arrows and 2 arrows. If you know both pairs of opposite sides are parallel, then it passes the test. So that's test number 1. Test number 2 is if both pairs of opposite sides are congruent. So if you see a quadrilateral and you know that this side's congruent to this side and this side's congruent to this side, then it passes the test. Remember, it only has to pass one. But here's an example of failing the test. This is an example of how to fail this test. Say you have a quadrilateral, and all you know is that this side's congruent to this side. That's not enough information to pass the test. Therefore, you don't know if it's a parallelogram, and this gets a big fat F. Okay? Third test. If both sets of opposite angles are the same, it passes. Both of them have to be congruent in order to pass, not just one. Aren't these just like the properties? Yeah. Okay, it's very, very similar to the properties. There's one that's a little different. Test 4. If your diagonals bisect, then it's a parallelogram. Okay? If both of them bisect. What if I don't know that they bisect? I don't know that they necessarily bisect. Oh, that's really bad. But I do know that they share the same midpoint. Is that enough? What do you think? Isn't that what we kind of did yesterday? So if I don't know that they bisect, but I know that they share the same midpoint, that's good too.
That's for example 4, right?
Yeah, you can put that here. Okay, the one that's a little different, that doesn't necessarily go with the properties, test number 5. If you know that one pair of sides are the same, and the same pair of sides are parallel, then it passes the test. It doesn't matter which side, so it could be the opposite pair. It could say, well, this is the same as this, and this is parallel to this. As long as you know both. You have to know both in order for it to pass. That's test number 5.
Wait.
Yes. Tape.
Does it have to have 4 sides to be a parallelogram?
It has to have 4 sides to be a quadrilateral, and then it can only be a parallelogram if it's a quadrilateral.
Okay.
So yes.
Can you
Yes.
explain that last one?
Yes.
Again?
This is just test number 5. Okay? One pair of opposite sides have to be parallel and congruent,
Okay.
and it passes the test. One. It doesn't matter which side, just one. Yes. Or both sides can be congruent and not know it's parallel, or both of them can be parallel but not know congruent. But if you only know one, then it has to be both. Okay, so let's try this guided practice 1A and 1B. Well, they don't give us any dashes on 1A, but they actually give us measurements. So we're wanting to know, by the theorems, is this quadrilateral a parallelogram? Well, think about all the tests we just learned. Does it pass any of the tests? Yes. The one that tells me that these two have to be the same and these two have to be the same. So, yes. And you could, it doesn't say right here, but if it says justify your answer, then you would say by test, opposite sides are congruent. Something similar to that. Tell me what test you used.
Can we use like the numbers? Like 6?
Well, you could, but I don't have those memorized, and people might do them in different orders. That makes sense. So, I mean, you can. I can always go back and learn it, I guess. I don't have them memorized, though. Okay, we know one pair of sides are the same, and one pair of angles are the same. Is that enough to pass the test?
No.
I don't think so. Now, you could say, well, I know that's 85 and these two have to be the same, but does it pass one of the 5 tests we talked about?
No.
So, no. Okay, try 1 through 6. Try 1 through 6. All you're doing is saying, does it pass the test, does it not? If it does, use a couple words to tell me which test it is. So, opposite sides congruent.
You don't hear me abbreviate, do you?
Mm-mm.
Number 4 would be like number 4.
Nope. All right. What y'all say for 1?
Yes.
Yes, I agree. And the reasoning, I would put opposite sides congruent. Both opposite sides congruent. Okay? Now, 2, don't let this trick you. Because remember, our test is that one has to be parallel and congruent. I don't see congruent marks, but do I know that they're congruent? Yes. For some reason, when I was in geometry, that always tricked me because my eye was trained to look for the dash. And I didn't see a dash, so I was like, oh, doesn't pass. But 3 and 3, that means they're the same. So yes, it does. And I would put 1 pair parallel and congruent. Something like that. 1 pair of sides, parallel and congruent. What about 3? Nope, not enough. 4? Nope, not enough. 5?
Yes.
Yes. Both diagonals bisect. What about 6? No. Okay, so from this chapter, you need to remember those tests, okay? Because on your test, it'll look just like this. On your test on Thursday, there'll be scenarios just like this. And you have to know whether they pass or fail. Okay, so in this practice, we're saying we don't know if they are parallelograms. But if they were, this is what would happen. So in 3A, find x and y so that each quadrilateral is a parallelogram. Well, if this is a parallelogram, don't the opposite angles have to be the same? So I would set 56 equal to 7x, and then 4y plus 4 equals 5y minus 26, because this has to be the same. Well, opposite angles are the same, right? So, if this is a parallelogram, then that has to be true. So, x would become 8.
Yes,
And then this would become 30. Bless you. Okay, try 7, 8, 9, and 10. 7, 8, 9, and 10. Try those 4. I'm going to give you a couple minutes. Try 7, 8, 9, and 10.
107, 100, or 106?
106, I believe. I don't know. What do y'all think?
106.
I think it's 106. Uh-huh. Yeah. So remember, one property of parallelograms is that when the diagonals, oops, you can't see, when the diagonal cuts it in half, it makes it into two congruent triangles. So if they're congruent, then this angle is the same as this angle.
So it's point, so it's supposed to be the little angle mark?
Yeah, so those two, yeah. So here, this is going here, and this is going here. And the one way to know that is you see this little circle at the top? That's a degree mark. I got positive. Because you subtract 1x and you get a positive x, and 11 minus 9 is 2.
What?
Are you on 10?
I'm on 9. 9 could be.
No, just think about it.
Oh, never mind. Wait. Oh.
Has anybody figured out 10?
No.
I'm trying to see if there's like a way to do it by elimination or substitution. So, look at the. Yeah. Man, that's complicated. So, do y'all remember substitution?
Right. Okay.
from Algebra
hold on.
1.
Did I do that right? So 6y, 6y, 2y? Like, I don't know. Or
I
3y?
can't read that, dude. I don't know.
I mean, like, so do you just set x equal to 2y?
No.
No? Okay, that's what I did.
Okay, let's check the other three real quick. Okay, check 7, 8, 9. Well, I got 2, 29, 8, 9, 7, and 11. How'd I get 9 right here? 3y plus 5 equals 5y minus 13. So I subtracted 3 and got 2, added 13 and got 18, divided by 2. Good on those three?
Oh.
Let's talk about 10 real quick. So, any way you worked it out, there was an x and a y on both. Well, these two have to add to be 180, right? And so do these two. So I did 2x plus 2y plus x plus y equals 180. So that's the first one. And then a second way is x plus y plus 4x plus x equals 180. So this was the second way. Well, I went ahead and combined all these. So this became 3x plus 3y equals 180. And then 2x plus 5y equals 180. Are y'all watching? Because this is new. We haven't done this. You did it in Algebra 1 last year. So then I was like, well, can I solve for x? So I subtracted 5y. And then I divided all that by 2. And I got x is equal to 90 minus 5 halves y. Well, I got x by itself. By substitution, I can plug this in for x and solve for y. So I did it on a separate piece of paper. So instead of writing x, I'm using this same equation right here. I plugged in all of this for x. So I got 3 times all of that plus 3y equals 180. And then I distributed. And then this is negative 7 halves. So negative 7 halves plus 3 is negative 4 1/2. And then I subtracted 270 and divided, and I got y is equal to 20. Well, now that y is equal to 20, I can plug it back into this same equation, which I did right here. And so 3x plus 3 times 20 is equal to 180. 60, subtract x is equal to 40. I don't know. You want something like that on your test?
No.
Why? That's an Algebra 1. You did, and you got the same thing? What'd you do? Let's see. I can put it up here for you to see.
I don't know if it makes sense.
Okay. So, this is what Jackson did.
Okay, so I set them equal, and then I got it down to x equals 2y.
You set these two equal. Oh, and then you...
Plugged that into the bottom. So
Ah.
x equals 180 and
Yeah. Okay, so Jackson did opposite angles, right? And then she subtracted 2y, which 4 minus 2, and then she subtracted x. So she got x by itself that way, which is way shorter.
Right.
So if x is equal to 2y, then...
I plugged in on the bottom, so it's
Yeah.
equal to 180.
Yeah. Good job.
You go, girl.
Y'all, this is an Algebra 1 standard. Y'all know how to do this. Or you did.
Good morning.
You did and you forgot. Remember substitution and elimination?
That was fun.
Okay, next page. One last thing. So it says to graph, which I'm not going to make you graph. If you want to graph, it'll probably be easier in some circumstances. So I'm not going to check for graphing. If you want to, cool. If you don't. There's graph paper over here. So here's the deal. They have given us 4 points of a quadrilateral. And we have to determine if it's a parallelogram by using what they tell us to use. So if they tell us that we can only use slope formula, well, is there a test that only uses slope formula?
Yes.
Yeah, because remember test number 1 that we talked about? Both pairs of opposite sides have to be parallel. Well, if both pairs of opposite sides are parallel, then they're both going to have the same slope. These two will have the same slope, and these two will have the same slope. So A, B, C, and D. So I'm going to have to use slope formula how many times? 4. Because I have to see if AB has the same slope as DC and if AD has the same slope as what? BC. So these two have to be the same and these two have to be the same. Do y'all remember slope formula? Y2 minus Y1 over X2 minus X1. Okay, so let's look at AB. I would have 3 minus 0 divided by 1 minus 0, which is just 3 divided by 1, which is 3. And then CD, these two right here, I would have 0 minus 3 divided by 4 minus 5, which is negative 3 divided by negative 1, which is 3. Are those the same? Okay, check. Okay, now we have to do the other two. So these two don't have to be the same as these two. They just have to be the same as each other. So A and D. So AD, I get 0 minus 0 divided by 4 minus 0. Is this 0 or undefined?
That's 0. Wait. Yeah, that's 0. That's 0 because it's just well.
Okay, so then we have 3 minus 3 and 5 minus 1, which is 0 divided by 4, which is 0. Okay, well, because these two are the same and these two are the same, yes, determine whether each figure is a parallelogram. Okay, so yes, both pairs opposite sides are parallel. Okay, so 12 is the same exact way, so I'm not going to do that one. 13 tells us to use what? Distance. Well, it's the only test that uses only distance.
The one with the
Distance, not midpoint. Distance and midpoint are different. What? Opposite sides have to be congruent. So if this has the same distance as this, and this has the same distance as this. Well, I don't know about you, but I do not want to do the distance formula 4 times. You could, but I don't really want to. So that's when I'm going to pull in the handy dandy graph paper. So I'm going to make a little graph. And then I might have to use distance because I can't count boxes sideways, right? So let's just see what happens. Negative 1, 0. So here's R. 3, 0. Well, bingo. I don't have to use distance there, do I? 2, negative 3. That's T. And then negative 3, negative 2. That's U. Wait. Negative 3, 2. Check. Negative 1, 0. 3, 0. 2, negative 3. Okay. Well, this looks kind of funky, right? Does it look kind of funky to you? What's the distance of RS? 4.
4.
Okay, let's find the distance of UT. Well, using the distance formula,
Oh.
girl with long hair swoop to the side, 2 eyes and a nose. I feel like that's a Christmas song. Is that a Christmas song?
No.
You sure?
Mathematical.
Negative 3, negative 2. T is 2, negative 3. So, X is first. 2 minus negative 3 squared plus then Y's negative 3 minus negative 2 squared. That's 5. 5 squared is 25. Negative 3 minus negative, that's a positive, positive. So negative 3 plus 2 is negative 1. Negative 1 squared is 1. So this is a square root of 26. This distance is a square root of 26. Is that the same as 4? Well, what would the square root have to be 4? 16. Is that square root of 16? No. So, this does not pass any tests. We're just using the test to determine if they pass. But you have to use it by what they tell you to use. They told us to use distance. I saved some time by only doing the distance formula once. Okay, one more. Because you know how to do midpoint. We did that yesterday. So let's use distance and slope. Well, the only test that passes distance and slope is when one pair of opposite sides are parallel and congruent. So if this is S, T, U, V, first of all, let's just check and see if they're parallel. Because if they're not parallel, then I don't even have to worry about the distance. So I need to find the slope of ST and the slope of VU. Well, are they parallel? Huh? Yes? Okay, so I'm going to graph it because I would way rather graph than do the distance formula. So I'm going to graph ST and VU and see if their distance are the same. So S is -2, +4. T is -1, -1. U is 3, 2, 3. Man. Come on. Am I going to have to use the distance formula?
Yes.
Yes. Okay. So, what about this? I'll find the distance of ST. You find the distance of VU. Go. Find the distance of VU.
What's that coming?
Hope this works. Because I don't want to find the other side. What y'all get for VU? Woo! Thank goodness. Okay, so because they're parallel and the distance are the same, by all good things, yes, this is a parallelogram, one pair of sides are congruent and parallel. So could it have been really tragic if that didn't work? Because if that didn't work, would we have had to test the other side? Yeah. And that would not have been fun. Okay? Alright, that's it. You know everything you need to know. So, what we're going to do is practice.
No. Okay.
It's practice. So, I do want you to do all 1 through 11. 1 through 11. The first 4 go super quick. Okay? On this 5 and 6, it says graph each quadrilateral. That's up to you. But on the distance one, on 6, if you don't graph it, then you have to use the distance formula. So for number 5, I would use the test where the two sides have to be, opposite sides have to be parallel. Like what number was that we just put on our notes? 11? This one's like number 11. And then number 6 is like the last one we just did, which is number 15. Okay? So finish 1 through 11.